Hi guys, welcome to the lecture number 4 for our PyTorch series. So today we'll be discussing a regression in little more depth and trying to understand more functionalities of PyTorch, and as usual guys, I'll be giving you a line by line walkthrough of the code that I'll be using so that you can really understand everything in depth and leverage PyTorch as a tool to train neural nets and do any sort of other stuff as well. And lately coding on AI tools has become relatively a thing, and now you don't actually need to go in depth of a lot of syntax. You don't need to memorize it. You actually never needed to memorize it, but just understanding the foundations and fundamentals would be the only skill required. So just stay along and I'll be walking you through every line of code. So guys, let's just start. So firstly guys, today we'll be doing our neural nets training on a GPU. So what is GPU? GPU is nothing but it's graphics processing unit. So essentially guys, I'll try to see if I can include a lecture on GPU and CUDA, but the main thing that you need to understand is that CUDA is a platform that's developed by NVIDIA specifically in order to manage GPUs, and GPUs were first made on the context of video gaming. So if you would know that video games are require high compute and related stuff, so they were built on that. But now GPUs are like the prime use of GPU has been specifically in training neural nets. And the main idea is that if you would know neural nets, right, they require a lot of matrix multiplication and all. So all those type of computations are easily like in some cases it's 100x more faster than CPU, because GPU has the feature for parallel processing. So a lot of stuff happens in parallel and then you get the result that really speeds up the process, and parallel processing is something that's not possible in CPU. So that's pretty much it. So here we are just trying to just do one thing, that if you're coding on Google Colab, just go to change your runtime and just let's just see that which one is selected. Make sure T4 GPU is selected. Let's just save, and then you can just run this. So you would be able to see that using device CUDA, so we have now access to T4 GPU. So now let's get started guys. We are just importing libraries. That's done. Now here we are just setting seed, that is just out there to uh, get some sort of consistency in the results, which is okay. You can skip this part as well. So guys, what we are trying to do first of all is we are trying to generate a synthetic data set. Okay, so what type of data set we are trying to do? We are trying to just generate something like x1 square minus 3x square something something. So it's a function that the neural net needs to follow along, and y is extensively a function of x1 and x2. Okay, so you have y that is dependent on x1 and x2. So I think that much is pretty much clear, right? So that's okay. And the main thing for this regression set of challenge that we have two variables x1 and x2. These are our independent variables, and y is a function of x1 and x2, and it is defined in this way, that it's 2x1 square minus 3x square plus this something sine function as well, and some sort of noise term as well. So everything is random only. So y is extensively dependent on two features, x1 and x2. So now we have this as well. So now we have our data set as well. Now this is also done. Now let's move forward and let's try to understand the further part of codes. So guys, what we are doing over here is we are trying to convert x and y to float tensor. So in my previous lecture also I told you that why we need to convert everything into tensors is there are two reasons. One, tensor is the building block of PyTorch. So you would be able to maximize on efficiency if you use tensors everywhere. And second reason is here we are using GPU. So tensor, when tensor was designed, it was designed to just ace the performance specifically on GPU. So we are doing that, we are just converting it into that, and just we are stacking x1 and x2. Okay, so column stack, what it does, it just stacks x1 and x2 like column wise. And then for y we are just reshaping it into -1 and 1. In the last lecture also I have like shown you these things, right, just to give you a glimpse of how things will look like. Let's just copy this line of code. Okay, and let's just paste it over here, and let's just print. So see guys, if I'll just type P, it would come up. If I'll just type P again, I think it would come if I just do like this. So you can also guys use this set functionality in Google Colab, just that you could also see that how effective and easy now coding has become, but understanding the basics and foundations is the only skill that's required. So you are able to see how these things got stacked up, right? Column stacking, and now you have a simple -1 1 you have done, so you will get a column vector for your labels. So guys, that is there. So labels are continuous labels in case of regression. Everything is clear. Also guys, I have seen few people ask that why this float is being used. So guys, see, we are using floats because we want our weights and everything to be in floats, so that is the main part of it. Then guys, we are just scaling x and y down so that we could just like, it's a standard practice, right? So you would have studied about scaling. If you would haven't, let me just take a moment. So what happens guys is that we are using standard scalar. So what is it doing exactly is that what it does for x is it takes mean and it takes the standard deviation, and for all observation it's going to do like this: xi minus mean divided by st. So this type of transformation we are doing so that our inputs can be in a particular range, so that neural networks convergence can be smooth, and we'll have other benefits as well, that there wouldn't be any outliers and stuff. Now guys, this is very important. Here we are moving our x scaled and x y scaled to GPU, okay, because we are using GPU. So device is equal to CUDA, so that means we are using GPU, since that's the main idea, right? That's pretty much done. So now we have done this much code as well. Now let's just try to understand. So guys, what happens in a neural net specifically when it comes to PyTorch and regression? All you need is, specifically, now you have access to AI tools, so you need to just define a neural network. You need to define a loss function. You need to define an optimizer if you are using one, okay? And the fourth thing is you need to start training. That's it guys, you just need to remember all these things, okay? Remember these four things, and then whenever you're doing something, just experiment with a lot of stuff. You would probably reach to a good solution, and try to explore a lot of things on internet as well. Specifically use other LLMs, create a layer on top of that. Just try to enhance your knowledge based on what we have. So guys, what are we doing? We are creating a neural network. Now how is our neural network created? So first of all, we are saying that let's have two neurons in the input layer, okay? Then let's have 32 in the second layer. Then let's use ReLU, and then let's have 64. Okay, so we are using 64, then we are using 32, then 16, and then 1. So guys, this is how everything is connected, and we are using a dropout. So dropout is a functionality that helps us cut out some connections in between, just to make sure that the model doesn't overfit. So this is a random neural net architecture that I have chosen. You can choose any according to you, and you can experiment with it as well, right? Just try to increase its depth, see what happens, and just play around. So for loss function, we are choosing MSC. So MSC is the most common form of loss functions for linear regression. So you're able to see that, okay, for linear regression based problem, the coding is not difficult, just understanding how to do the setup is a thing. Then I'm using Adam optimizer, okay, then everything is there parameterized, okay? Just try to go through it, it's not very difficult, right? We are just using Adam with L2 regularization via weight decay, so you don't need to go into the maths of it, but you could just understand that, okay, this type of optimizer optim function is there. I can get in any optimizers and then study about the parameters and try with different parameters. That's all you need to do specific to regression. So now once we have defined all these things, the next things that comes up is training. So guys, see, this is the training loop. I have seen few people getting confused over here, and I'll try to make it very simple. See guys, try to understand what happens in one epoch. So the entire data set, okay, the entire data set is seen by the model in one epoch. Why we are doing batches? So we are creating mini batches. So what will happen is that once one epoch will start, a mini batch of 32 would be sent to the neural network, and everything will happen, a forward pass and a backward pass, and then another time you will be sending 32 until you exhaust the data set. And based on, we have just 1000 samples and we are just having 200 epochs, so it's not a lot of computation. Not sure how much time it would take on a CPU, but guys, don't do these things on your PC. Your PC would just sit down but it's best to use Google Colab for these things. And guys, even I think you can go for the paid version of Google Colab. It's $12 a month. That's okay if you wish to experiment more on PyTorch and do the learning. Right now, even I'm not using the paid one, I'm using the free one, but yeah, this I'm keeping you informed. So now just try to understand what we are doing. We're just trying to start the training loop. So in one training loop, what will happen is model.trains. So we'll start the training process, epoch loss. So initial loss per epoch would be 0, makes sense. Then guys, what we are doing over here, we are just shuffling the data set because we need to make sure that we introduce some sort of randomness in the data set, right? And the next thing is what we are doing, we are doing mini batch training. So our data would be sent into the neural net in mini batches of 32. So then we're gonna do that, and we are just taking like the start index and the end index to just like extract the mini batch, right? So what is I might be 0, so we need to start from 0 and then go to the end index. What is end index? Start index plus batch size, so 32. So 0 to 32, you would have 31 things that would go inside the neural network. Then you would compute the loss, then you would clear the gradients, then you would do backward. I have shown you how to use dot backward specifically. It's going to be doing your compute gradients, and then you're updating the weights, and then you're increasing the, you're just like keeping a track of the loss. And guys, that's pretty much it, right? Rest code is not there. It's all used for plotting and everything purpose. This is raw boilerplate code. You could just find it anywhere on the internet. Only thing that I want you to focus on is that you need to understand how to define a neural network, right? See, when it comes to seeing PyTorch for the first time, this might be little confusing for some of you. But as I said, guys, things have changed, times have changed. We don't need to focus a lot on these kind of things. We need to focus on the basics, right? For instance, what will happen if I'll increase the structure of the neural net? What will happen if I change the loss function? What will happen if I try with the different optimizer? What will happen if I increase the epochs? What will happen if I change the batch size? What will happen if I like specifically for other problems, you'll have different architectures. So just experimenting is the only skill that you would be needed. So you'll be able to see how quickly 200 epochs were trained. And this just happened because we are using, if you see, you're using device CUDA, so we are using GPUs, T4 GPU. So it really helped us like get to a lower loss, and this is just for experimentation purpose, right? So if you would see the R square, so the R square is 0.93. It's good, but it's just for experimentation. Don't take these results very seriously and stuff. So guys, mainly I just wanted to show you how you could just like get into the habit of training your neural net specifically in mini batches, which is a good practice. So just try to define the epochs, then define the mini batch, and then in every batch you need to do training, and then you need to update your weight. So guys, neural nets just work in this way, right? You have define a neural network architecture, define a loss function, define an optimizer, and define the training process. So in here we are just doing mini batch training. Okay, mini batch training. So that's pretty much it, guys. What is mini batch training? It's just that your data, let's say you had right, so you're having 200 epochs, right? So in one epoch, the entire data set gets passed to the, in one epoch, entire data set gets passed to neural net, right? That's pretty much clear. But the thing is that we are not passing it all at one go. We are passing it in mini batches of 32 so that we could have better optimization, right? We could have better optimization, right? We can, our neural nets will not explode, right? Like back propagation will be easy. So all those things you need to take care of mind, and just try to be along in this series. Just try to practice this much coding. Slowly everything would be covered in this course. And guys, please subscribe to my YouTube channel. I can guarantee that I would be delivering best lectures when it comes to PyTorch, and you would learn a lot. As I said that there might be some use cases wherein you need to apply PyTorch, because let's say you have a regression use case on a big data set and you feel that neural nets are a solution to it. So if you just understand this much, you could just take up some time and implement that, and now you have AI tools, they're going to assist you, and it's going to be a very quick process. But just knowing basic foundations would really help. On that note, I would like to end the lecture, and guys, have a great day, and please subscribe to my YouTube channel.